Hey guys, welcome to Target 2B. It's the relationship between sine and cosine, right? We're looking at two of our trig ratios. I didn't make a vocab video for this target because there's only one vocab word and we actually already know it. It's not a new vocab word. So the only thing we really have to keep in mind is complementary angle. And complementary angles are just two angles that add up to 90 degrees, right? We looked at that at the beginning of the year with our geometry vocab. So that's really our only vocab word. So let's go ahead and look at example 1. Example 1, right, we're going to use this triangle XYZ, to answer all these questions. If we look at A, first thing, is there actually a typo? This should say the angle of X plus the angle of Y. This should say the angle of X plus angle Z. Sorry. Right, so angle X plus angle Z, not angle Y. So here, right, if I add up, what we're going to use for this is actually our triangle angle sum theorem. If I add up all these angles, so angle X plus angle Y, or angle Z, plus angle Y, right, if I add all those up, that's going to equal 180 degrees. Right, but what do I know about these angles? Well, I don't know anything about angle X and angle Z, but I do know that Y is 90 degrees, right? So I have angle X plus angle Z plus, now instead of angle Y, I'm going to put 90 degrees. Right? So now if I subtract that 90 degrees, angle X plus angle Z equals 90 degrees. Right? So angle X plus angle Z is simply 90 degrees. So basically what we know is these two angles are complementary. So angle X and angle Z are complementary. So that's what A is pretty much asking me to find. Well, if angle X plus angle Z are 90 degrees, they're complementary angles. Alright, so now I want to use trigonometric ratios to write xy over zx in two different ways. Right, so I have xy and I have zx. So that's xy and zx. Okay. Well, the first thing I'm going to do is look at angle z. If I'm looking at angle z, then xy is my opposite side and zx is my hypotenuse. So sine of z equals xy over zx. Okay. However, if I look at angle x, right, then xy is my adjacent side, where zx is my hypotenuse. Right? And adjacent over hypotenuse is the cosine. Right? So the cosine of x equals xy over zx. Okay? So the sine of z and the cosine of x equal the same thing. Looking at z, now I want to write zy over zx in two different ways. So I have zy over zx. Now again, if I start by looking at angle z, right, now this is my adjacent side, zx is still my hypotenuse, so cosine of z equals zy over zx. But if I look at angle x, right, this side is the opposite side, so I have opposite and hypotenuse. So for cosine of x, or for x, sorry, the sine of x equals zy. Ooh, we'll erase that really long Z tail. So the sine of x equals zy over zx. Okay? So pretty much what we have found so far is in this right triangle, the sine of z is equal to the cosine of x, and the cosine of z is equal to the sine of x. Right? So those opposite things are equal. Alright. And we kind of already made these conclusions. The sine of z and the cosine of x, well, they are equal. Same thing with e, right? The cosine of z and the sine of x, they are also equal. Okay? So our main conclusion here is when you have two complementary angles, if two angles add up to 90 degrees, their cosine and their sine are going to be equal. Okay? So if they add up to 90 degrees, their cosine and their sine are going to be equal. Alright. Looking at example 2, it says determine and compare the trigonometric ratios for angle A and angle B, as well as the 20 degree and 70 degree angles. Then compare your findings from triangle number 1 to triangle number 2 and draw a conclusion. Alright, so let's look at triangle number 1 first. I'm going to find my ratios for angle A. Okay, so here's angle A, my opposite side, my adjacent side, my hypotenuse. Okay, so the sine of A is equal to, right, 8 over 17, opposite over hypotenuse. The cosine of A is equal to 15 over 17, and the tangent of A is equal to 8 over 15. Okay? So those are all my ratios for angle A. Now I'm going to look at angle B. So I'm going to relabel my sides. I have opposite, adjacent, and this still gets to be my hypotenuse. So the sine of B is equal to, right, opposite over hypotenuse, so 15 over 17. The cosine of B, right, adjacent over hypotenuse, so 8 over 17. And the tangent of A equals 15 over 8, opposite over adjacent. So far what we notice is what we saw the last time still holds true, right? My sine and my cosine, my sine of A and my cosine of B are equal, and my sine of B and my cosine of A are equal, right? So they're equal to those opposite trig ratios in the opposite angle. Okay? Looking at triangle number 2, right? Let's look at my 20 degree angle. The sine of 20 degrees, right? Well, I have opposite, adjacent, hypotenuse. So the sine of 20 degrees equals f over e. The cosine of 20 degrees equals d over e. And the tangent of 20 degrees equals f over g, right? Opposite over adjacent. Just finding all those trig ratios. Then, looking at looking at my 70-degree angle, right? The sine of 70 degrees, right? And then I have opposite, adjacent, hypotenuse, right? So sine opposite over hypotenuse is d over e. The cosine of 70 degrees would be adjacent over hypotenuse, so f over e. And the tangent of 70 degrees would be opposite over adjacent, so d over f. So again, we see that same relationship holds. My sine of 20 is equal to my cosine of 70, and my cosine of 20 is equal to the sine of 70, right? And remember, these angles add up to 90 degrees, right? Angle A and B are going to be the same thing. Even though I don't know their measure, since they're the two acute angles, they have to add up to 90 degrees, okay? So anytime you have complementary angles, this relationship is going to hold. Alright, let's look at our last set of examples. Example 3 is asking for the value of theta. So now we're going to use this relationship in a different way. So if I have sine of theta equals cosine of 25, right? Since these are two different trig ratios, it's not that theta equals 25. They're not the same angle. These two angles here are complementary. They add up to 90. Right? So if I have sine of theta equals cosine of 25, that means theta plus 25 has to equal 90. Right? So subtracting 25 from both sides, theta equals 65 degrees. Not too hard. Looking at our next one, right? Same thing. These angles have to add up to 90. So 80 plus theta equals 90. Subtracting 80, theta is going to equal 10 degrees. Okay. Looking at our next example, I have theta plus 10, right, equals 90. So theta, remember, theta is just a variable. Theta plus theta is 2 theta plus 10 equals 90. Subtracting 10, 2 theta equals 80. Dividing by 2, theta equals 40 degrees. Okay. And then same thing for our last one. I have theta minus 45 plus theta equals 90 degrees. So again, I have 2 theta minus 45 is going to equal 90 degrees. So here I'm going to add 45 to both sides. So 2 theta equals 135 degrees. Grab the theta there. So then divide by 2. So theta equals, right, 135 halves. Or should be 67.5 degrees, I believe. So those problems aren't too bad. Just remembering that if you have the sine of one and equals the cosine of the other, they're complementary angles. Alright, that's all we've got for tonight. I'll see you guys tomorrow.